Today we will study about colloids. We know that there are two types of mixtures, homogeneous mixtures and heterogeneous mixtures. In case of homogeneous mixture, true solution come in this category, whereas heterogeneous mixtures are colloids and suspensions. So a colloid is a heterogeneous system in which one substance is dispersed as very fine particles in another substance known as dispersion medium. The substance which is dispersed is known as dispersed phase. Like in case of solution, we have solute and solvent. Solute is in small quantity whereas solvent is in higher quantity. Similar is the case here. The dispersed phase is in lesser quantity whereas the dispersion medium is in higher quantity. The particle size in case of colloids is from 1 nanometer to 1000 nanometer. See, the solution, we have particle size less than 1 nanometer, and in case of suspension we have particle size greater than 1000 nanometer. In this chapter, in this topic, we will study about the classification of colloids, how they are prepared, their properties, and how they are purified. So let's begin with their classification. Classification of colloids. We can classify colloids using different criteria. These are physical state of dispersed phase and dispersion medium, nature of interaction between dispersed phase and dispersion medium, types of particles of the dispersed phase. Let us take these one by one. First with physical state of dispersed phase and dispersion medium, that is whether they are solid, liquid or gas. So dispersed phase, when solid is dispersed in solid, means dispersed phase is solid as well as dispersion medium is solid, it is termed as solid sol. The examples are gemstones. Then solid dispersed in liquid, it is known as sol, like paints, cell fluids, etc. Then solid dispersed in gas, it is termed as aerosol. Examples are smoke and dust. Then liquid dispersed in solid, it is known as gel. Example, cheese, butter and jellies. Then liquid dispersed in liquid, this is emulsion. Example is milk, hair cream. Emulsions are of different types, oil in water type and water in oil type. Means when dispersion medium, that is more, it is, if it is water, then it is oil in water type. If the dispersion medium is oil, then it is water in oil type. Oil in water type is milk, water in oil type is butter. So then we have liquid in gas, it is termed as aerosol. Examples are fog, mist, cloud, etc. Then gas dispersed in solid, termed as solid sol. Pumice stone, foam, rubber. Then gas in liquid, it is also termed as foam. Froth, whipped cream, soap, leather. So let us see these examples one by one. This is solid dispersed in solid, that is solid sol. A gemstone is shown here. Then solid dispersed in liquid, it is termed as sol, paint and ink. Then solid dispersed in gas, aerosol. Example is shown here, smoke. Then liquid dispersed in solid, known as gel, jelly, butter is shown here. See, butter is also in the category of emulsion. Then liquid dispersed in liquid, it is emulsion. Milk is shown here. Then liquid dispersed in gas, it is aerosol. Some sprays are there, aerosol sprays. Then gas in solid, solid sol. Pumice stone is shown here. Sponge is also there. Then gas in liquid, foam, soap foam and whipped cream. Then classification based on nature of interaction. It is lyophobic colloids and lyophilic colloids. Lyophobic colloids are solvent hating colloids. See, phobia word is to hate. So, and lyo is for solvent. So, when there is no interaction between, no attractive forces between the dispersed phase and dispersion medium, it is termed as lyophobic colloid. When metals and their sulfides simply mixed with dispersion medium, they don't form colloids. They need some stabilizer. So this stabilizing agent, it makes the colloid like oil and water. They are not mixed directly. So we need some stabilizer to stabilize these colloids. So they need special methods to be formed. They may be chemical method or physical method, but there are special methods. They are irreversible in nature, means once the dispersed phase and dispersion medium get separated, they again need to be formed. Again we need to apply the chemical method or the special method to form the colloid again. Then examples are gold, silver, ferric hydroxide sol, arsenic sulfide sol, etc. Then lyophilic colloids, as told earlier, these are solvent loving colloids. Philia means to love or attraction. These are directly formed by substances like gum, gelatin, rubber, etc. on mixing with suitable liquid. Like if we mix starch in water, in hot water, it will directly form a lyophilic colloid. These are self-stabilizing, means they are stable, means the components do not separate from each other. They are reversible. If somehow the components are separated, like starch and water, when they mix together they form the colloid, but somehow if they are separated, like the water is evaporated, they can again be formed by directly mixing with water. Some examples are gums, gelatin, starch, albumin in water. Egg albumin, when we mix it with water, it will form a lyophilic colloid. Then classification based on the type of particles of the dispersed phase. See, this is of three types: multimolecular, macromolecular and associated colloids. Multi means many. Multimolecular consists of many small atoms combined together, whose diameter when combined together will become of range of colloidal particle. Earlier the particles, the atoms or ions are of smaller size, that is less than 1 nanometer. But when they combine together, they give colloidal size particle. Then macromolecular colloid, as the term indicate itself, macro means big. So the molecule itself is such big in size that it is of the colloidal size, means it is in between 1 to 1000 nanometer. So molecules have size and dimensions comparable to colloidal particles. Examples are protein, starch, cellulose. See, all these are biomolecules which are macromolecules. So their colloids are macromolecular. Then we have associated colloids. See, in associated colloids also we have many molecules combined together, and in multimolecular also. But the difference is that in case of multimolecular colloids we have atoms combined together, but associated colloids are generally electrolyte solution which at a higher concentration and at a particular temperature only behave as associated colloids. So at low concentration they behave as normal strong electrolytes. At higher concentration they exhibit colloidal properties due to formation of aggregated particles which are known as micelles. You must have read micelles in class 10th. Soap solution form micelles, detergent solution form micelles, and they are the micelles only which help the soap solution or detergent solution for its cleansing action. So see, this is the micelle. This one molecule is a soap molecule. It has a lyophobic tail which is directed inwards. See, this zigzag portion is lyophobic tail, which is solvent hating, and this end, this COO minus, this end is lyophobic. philic, which is towards the solvent. So all the lyophobic tails, they are directed inwards and they form a sphere-like structure. This structure is known as missile. The formation of missile takes place only above a particular temperature as told earlier, and this temperature is known as Kraft temperature, and above a particular missile concentration known as critical missile concentration. So at normal concentration they behave as strong electrolytes, but when the concentration is higher they behave as missiles, because missile formation takes place only above a particular concentration, and this missile formation is responsible for cleansing action of soap. So this is about associated colloids, and cleansing action of soap is also asked sometimes. So this missile, the lyophobic tails, they are attracted towards the dirt or grease, they get attached to it. If dirt is here, this lyophobic tail gets attached to the dirt, and when rinsing or wringing action is done, this whole missile goes away along with water, taking the dirt away from the cloth. So this is about the cleansing action, and these are the three types of classification of colloids. In next video we will study about the preparation, the properties and purification of colloids. That's all. Thank you.